Hey, mathematical Padawans, this is Mrs. Bird. I am going through the project for Unit 3, focusing on specifically the questions presented in Lesson 13. So background information for this is that we got a wedding going on. That's pretty cool. And people, I'm guessing dragons, all the extended family, they are flying in literally from their faraway lands. So we're going to figure out their rate of change. They're changing in position because they're flying. They're flying some places. So we're going to be figuring out the rate of change. So looking at question number 1, let me get rid of that junk. We have information about a family that lives 165 miles away from the castle, and it takes them 3 hours to fly there. Now, what is the average rate of change for the trip? So I want to begin by reminding you about a very simple equation that is really, really handy, get used all the time. I call it the DIRT equation. Distance equals the rate times time. And I want you to think of the rate, and that can be the speed in this case. So we are trying to find the average rate of change for this. So I want to solve for r. So I would isolate r by dividing by t here. So now I have the rate of the dragon flying in this case. Dividing is equal to the distance that they travel divided by the time. So we do know that the distance that they travel to be 165 miles. Divide that by 3 hours. Oh, see, I'm starting to see this units, miles per hour. That makes sense as I relate it back to a rate. You can use a calculator. 165 divided by 3 is 55. So we have 55 miles per hour. Now I want to come back to why is this called the average rate of change and not just the rate of change? Well, because as any of you guys have ever traveled anywhere, you're not going at a specific speed for the entire trip, right? If I'm getting in my car, I need to back out of my driveway. That's one speed. I need to change into a forward movement. That's going to be a changing in another speed. I get a stop sign. I need to change my speed and stop. I need to accelerate out of the stop sign. So we're always going to be changing the speed, but on average, how fast were you going for this trip? So on average, they were traveling 55 miles per hour. Were they always going the exact speed of 55 miles per hour? Heck no. But over the 165 miles, they averaged 55 miles per hour. So that was question number 1. Question number 2 starts to talk about instantaneous rate of change. So this does give us a little bit of background information about some griffins that are flying. So griffins have a headwind. Oh, that's describing what a griffin is, not that they're fighting against a headwind. I can read. Okay, anyways, the dragons catch up to the griffins after 1.5 hours of traveling, and the dragon's speed at the moment is slowed to 35 miles per hour. So what does this speed represent? So I'm going to just underline that because that's the part that it's speaking about. At this moment, they slowed down to 35 miles per hour. This idea right here is really important because at that very minute, that moment, they are slowing down to a very, very specific speed. So this is not the average rate of change. This is very specific, saying at a specific time, at exactly this moment in time, they slowed down. So this is actually what we describe to be an instantaneous rate of change. Instantaneous meaning at an instant. At what instant were they moving? So this is an instantaneous rate of change. When were they traveling? 1.5 hours into their flight. So we know the instantaneous rate of change at 1.5 hours for that trip. So hopefully you're starting to see the difference between instantaneous rate of change versus average rate of change. So that was question number 2. And then question number 3, we'll do that one later. Question number 3, it says, after slowing down, the dragons could fall behind on their journey. What do the dragons need to do in order to ensure that their average rate of change stays the same for the entire trip? So we know from question 1, in this, we know that their average, question 1, sorry, rate of change, I'm going to call it the rock, was 55 miles per hour. Okay, that's what we know. But then now they're saying the dragons fall behind because they slow down. So if they've slowed down from their average, what do they need to do to bump back up to their average? Well, if they've slowed down from their average, they should probably speed back up. So they need to speed back up and stay above 55 miles per hour. So hopefully that makes sense. If we've slowed down a little bit to make up the time, we need to speed back up, and specifically we need to speed back up to be above 55 miles per hour. Okay, that is the 3 questions presented to you in this lesson. As always, reach out to me if I can help in any way.